Hi everyone. In this video we are going to learn about central and inscribed angles. So just some key vocabulary to get us going with today's lesson. You should be familiar with most of the words, but I'm just going to recap really quickly. Okay, central angle is an angle that has its vertex at the center and its endpoints are on the circumference of the circle, which just means they're on the circle. So this is an example of a central angle. Its vertex is at the center, and then its endpoints are A and B, which are on the circle or the circumference. So again, this is a central angle of a circle. An inscribed angle, on the other hand, has its vertex and endpoints on the circumference, but on like opposite sides. So an inscribed angle would look like this. So here its vertex is on the circle, and its endpoints are also on the circle. So that's an example of an inscribed. And the more I say these, the more you should know them. So by now you should know what central and inscribed angles are. An arc is just a portion of the circumference of the circle. So this is an arc, okay, or I could say this is an arc. That's a minor arc specifically. And a chord is a segment that connects any 2 points of a circle. So this is a chord. A diameter is an example of a chord, but it's a special kind of chord that goes to the center. Chord can be any line that has endpoints on the circle. So these blue lines are chords. Okay, a new vocab word for today in this video is an intercepted arc. I'm going to show you an example and then I'm going to write the definition. An intercepted arc is an arc that is created by a given angle. So if this is my central angle, let's say we're talking about angle IOE, then the intercepted arc is the arc that that angle opens up to. So this would be the intercepted arc of that angle. So we'd say arc IE is the intercepted angle. So it has the same endpoints as the angle you're talking about. I'm going to write this definition. This isn't the precise definition, but this is how I remember it. An intercepted arc is an arc created by an angle in a circle. Or you can say, or across from an angle in a circle. Okay, that arc will have the same endpoints as the angle. Same, endpoints as the angle you're referring to. Okay, we're going to use this vocab word throughout the video. The essential question for today is, what is the difference between arc length and arc measure? So arc length is the distance of the arc. Okay, so you'd measure arc length in like centimeters, inches, miles, kilometers, etc. Okay, it's a distance of how long that arc is. Whereas arc measure is the angle of the arc. So angle really tells you how wide the arc or the angle opens up. Okay, it tells you like the size of it in a different kind of way. So this you would measure in degrees. Okay, so distance is like if you're walking along it, how far you'd walk. Whereas arc measure is like, okay, if the slice of pizza is 60 degrees, right? That's how like big it opens up from the vertex. Okay, now that we have the vocabulary, let's get into the new knowledge. So I'm going to leave this review for you to do alone when you're done with the video. What we already learned how to do is to find the length or the arc length of AB. That's what we worked on in the last portion of the chapter. To refresh your memory, you're finding out how long the crest is. So I'd figure out how long the distance is around the whole circle, which is called the circumference, and divide it by how many pieces of pizza there are. So at the end of this problem, you should have an answer that's like blank centimeters, because you're measuring a length. What's new for today is that word measure. So if I want to find the measure of AB, that is different than the length. The length is how long it is from here to here, and the measure is how far that opens up. Okay, and we would write this, the measure of AB, as M of AB. So M stands for measure, and AB with an arc symbol over it is the minor arc AB. Okay, if I take a look at what information I have here, I have the length of the radius is 8 centimeters, but that won't help me now because I'm talking about a measure and not a length. And a measure is always measured in degrees. So the only measure I'm given in this problem is at 75 degrees. That is a measure. It's how wide this angle is here. Okay, and this is important because this is the measure of the central angle. It's a central angle because its vertex is on the center and its endpoints are on the circle. Okay, so the measure of angle, and I know this is labeled AB, I'm just going to call a center point C. So the measure of angle ACB, the central angle, I'm going to write that down because that's important, is equal to 75 degrees. Okay, that's the measure of this angle. What I want to find is the measure of the arc AB. So like how wide or what angle is this arc going at? And the theorem for today, or one of the theorems for today, is that the measure of the central angle, or the measure of a central angle, central, keyword there, central angle, is equal to the measure, keep saying that word measure, of the intercepted arc, or of the corresponding intercepted arc. I know it's a lot of words, but make sure you write it all down. Okay, so what I'm really saying with all those words is that if this measure of the central angle is 75, then the measure of the arc that intercepts it, which is the arc with the same endpoints, is also 75 degrees. So to find the measure of arc AB, the answer would be 75 degrees. It's just the same as a central angle, which I have a visual here for you to see that. So the red angle is our central angle. Okay, the red angle here is attached to the center, so it's a central angle. Okay, and we know that the measure of CAD is 50 degrees. And then it also gives you the measure of arc CD is also 50 degrees. So if you keep kind of spinning this around, if CAD here is 122.4, then arc CD is also 122.4. And you can see that here. If it's 71.2, then arc AB is also 71.2. So the measure of this angle is the same as the measure of this arc. It's a nice, easy theorem to remember. Now, there's one other theorem we want to look at for today, and that is about inscribed angles. So this is a theorem for central angles. Central angles are the same as the arc that intercepts them. If I have an inscribed angle, it's different because it's not at the center, its vertex is at the edge. So again, this is an inscribed angle. So ABC, angle ABC, is an inscribed angle. ABC is an inscribed angle, and we don't know the measure of ABC. All we know is the degrees of the arcs. So AB here is 150, and BC here is 110. And we know every circle has 360 degrees. So I could find AC by just kind of doing some solving steps. So total circle is 360, but I already have 150 and 110 used up. So 360 minus 150, 360 minus 150 and minus 110 degrees. There's 100 degrees left for arc AC. Okay, so if I do 100 plus 150 plus 110, it'll add up to be 360. Okay, so if I was talking about a central angle, and I'm going to draw that central angle. So here's the center. My central angle would look like this. From the theorem I learned in the previous problem, I know that the central angle is the same as the arc that intercepts it. So if this arc is 100, then this central angle is also 100 degrees. So the arc and the central angle are the same. But if we go back to this visual, is the measure of the inscribed angle the same as the arc? So for example, let me just pick a different number here. Let's say that this arc is 100 degrees. Okay, so arc CD is 100 degrees. The inscribed angle is CBD, it's the blue angle out here. So is the measure of that inscribed angle the same as the arc across from it? And the answer is no. The arc is going to be longer, the central angle is going to be smaller. And what's the relationship between 100.7 and 50.3? It's that the inscribed angle is half of the arc. And let's just test that with a few more examples. So if our arc is 40.8, our inscribed angle, or CBD, is 20.4. So CBD, or the inscribed angle, is half of the arc. So our second theorem today, let's get that back here. That second theorem is that the measure, where is it going? There we are. The measure of an inscribed angle is always half of its intercepted arc. Half the measure of its intercepted arc. So to go back with our example, I wanted to know the measure of AC, and then I can find the measure of ABC. So here's our inscribed angle, okay, and we don't know this, but we know that the arc is 100. So if the arc is 100, the measure of the inscribed angle is always half. So the measure of this angle is 50 degrees. Which you can go further to say it's always half of the central angle, which you can kind of see, like which one's going to be bigger, the central angle or this inscribed. And the inscribed is going to be smaller because you're like pulling it further back from this vertex. So you can also say the measure is half of the central angle. Just depends what you're given. Okay, so find the measure of AC, which the measure of arc AC would be written like this, which we can then use to find the measure of angle ABC, which is the inscribed angle. Or if you want to go backward, you can say, okay, if I know the measure of the inscribed angle is 42, then the arc has to be double that. So if this is 42, I know this angle has to be 84, and this arc has to be 84. So you can work both ways to solve for central and inscribed angles and their intercepted arcs. Okay, so these two theorems are what you really need to know and be able to tell me about by the end of this video. Okay, so theorem 1 over here, theorem 2 back up here. If you have any questions, feel free to ask, but otherwise, please study your notes and practice.